But this is also very exciting because we are working with our faculty members that are, two of them are here, and we are trying to do something for a university that some people think that should already be there, but it's also using emerging media. So I'm going to let our producer Michael talk about the technical part, but before that I'd like to ask Susie Lavalley, our faculty, to come here and say why we are doing this, the why question.
Okay, thank you. Well, this is quite the opportunity, and I always joke that I'm the least technologically capable person, so I always feel like a bit of a fish out of water when I'm here. But really, the project has emerged from some common goals that we have noted throughout our discussions with Michael on a previous TLEF project. We discovered that it was a really common goal amongst a whole bunch of different disciplines and a whole bunch of different courses to have students interact. This is a really bad model for this because I'm going to spill it, but interact with objects. So the problem is that for a lot of disciplines, objects and the type of objects these students are studying are unusual. They're fragile. They are difficult to source ethically. So things like human bones, human remains, diseased bones, fragile items of art from the Anthropology Museum. And after our initial discussions with here at UBC Studios, I went to a whole bunch of different collaborators across campus and started asking them, well, would you use materials, like would you use things that we can print in 3D? And we hatched this idea that it would be really great to have an advanced way of getting students access to objects, either in a virtual resource that can be launched online through photogrammetry, or some other means. One of the most common and most popular ones that people wanted to use was the 3D printing, which we have incredible capabilities already present at medicine in the Hive, but there's potential for us to go a lot further and to make this available to a lot of other disciplines across campus. So this may seem sort of obvious. And a lot of people are doing this in a very siloed sort of way right now. But the goal, and I think what really makes this unique, is that we were planning to bring this to a whole bunch of different faculties all at the same time by centralizing some of these resources and centralizing some of these ideas. So things like having human remains or long bones, for example, like a femur or a humerus off of someone that are donated, but they're usually donated off of a short timeline. We can then say, okay, we've only got 2 weeks to work with this bone, but we'd like to have a copy of it here. We can put it in the photogrammetry unit, or we can put it in the scanner. We can generate a file for this bone that can either be launched online or printed as a resource for students to actually physically interact with. Even things like soil aggregates, which I learned all about when I sat down and spoke with Maya Kurzik, whom some of you may know. Soil aggregates have certain properties and certain shapes. They're very difficult to illustrate to students because as soon as you pick up a soil aggregate and start doing this with it, you've got nothing. You've got a pile of dirt on the floor. Soil is not dirt. Somebody from LFS who may actually report me to my, so I have to make sure to watch myself. But this is important because we can actually print soil aggregates. We can take soil aggregates, which are really lumps of dirt. I'm not kidding you. That is what they are, because they have different shapes and different properties and different porosity. They have different surfaces. And we can generate aggregate kits for students to use in a lab to investigate things like how soil properties work. So a number of courses that are going to be using these resources need these for things like first and second year courses. So we're talking about a massive generation of really basic resources that's going to transform labs and hands-on learning for a lot of students across campus. And I am super excited to be working with these guys. I'm extra excited to print the submit button yesterday on the computer and actually get this project hopefully in the works. So I think, is there anything else you wanted me to add to that, Saeed?
I will have a time at the end.
Okay, I'll sit down then. You guys take it.
So, so Michael has worked with different people. The main purpose of
That's okay.
the project had two phases. The small, I guess the phase one was supposed to be only video, but then we talked about potentials of 3D scanning and also visualization, and Susie got excited as much as we are. And then we decided to have a portion of the first phase of the project dedicated to an R&D project. So that's the part that Michael is going to talk about. We worked with the Hive at medicine and also industry, and the portion that Michael is going to be talking about is the first phase, and then we can hopefully talk about the next phase. Is there anyone from the Hive here?
I think it's just me, but
Okay.
I'll do my best.
Yeah. So then we go into the next phase to see what's been done outside this project, and then how we can move forward. But I'll ask Michael to talk about what was done for the first phase.
Great. Okay, that works. Yes, thank you, Saeed. I'll just try to get things up on the screen. Here we go. So yeah, my name is Michael Sider. I'm a producer working at UBC Studios, and we produce media for the whole university, communications, marketing style media, also educational media. There's a team of about 10 of us, and I'm one of two producers, and I focus mostly on educational media, mostly working with faculty, and mostly video. But every now and then something comes along, more and more commonly, where we see pedagogical potential in emerging media, and we always steer away from using new technology just for the fun of it. But this is an example of a project where both Saeed and I said to Susie, had you considered virtual objects? And I think you said something like, can we do that? So that became an interesting moment. And began just by asking, first I'm just going to throw in that there was a lot of us involved. Susie approached us, but and earlier Susie was talking about the analogy of giving birth with a project as a faculty member, and I was thinking that often producers, we're trying to be midwives, so we're helping faculty give birth. And but once you've given birth, it takes a village to raise a child. So there was a lot of people involved. Just wanted to point out here within UBC Studios, we had Kirk Harrison, who's our head of post-production, and Andrew Wang, and they're both in the back, who's oversees our operations. And they both put a lot of work and ingenuity into figuring out how to do what we were doing. It wouldn't have happened without either of them. Also, the exploration we've done wouldn't have happened without the Hive. Claudia Krebs is here, who very generously gave us access to their 3D scanning equipment and the students that knew how to use it, so we were able to try that out as part of our process of working through. And most notably, Ishan spent a whole afternoon with Andrew and I scanning a bear skull and a rat, and then editing those objects into OBJ files that we could take away at very high resolution, which was really crucial in our process of trying to figure out what technology we should even use. So, and then we also got to go and visit Finger Food Studios through a connection with Saeed, based out in Port Coquitlam. They're a pretty big company doing a lot of photogrammetry and other emerging media using applications of corporations. They're doing a big project, AR project with MEC right now, where you can, with your iPad, you can climb inside a tent and look through the fish screen out into the room to figure out how big the tent is. So they gave us a lot of good input and advice and showed us some of their big scale rigs and did some scanning for us, and again helping us along figuring out what we should be doing. So as a producer working with faculty, I'm always trying to start at, well, what's our learning goals? How do we work toward those learning goals instead of what's the exciting technology? What do we want to play with? So talking with Susie originally around the videos, but then also about the virtual objects. Some really key things came up for students to learn how to identify the different animals and to be able to compare between, differentiate. The detail and resolution and also visual information like color and texture are really crucial. So that was something that we had in mind as we were trying different modalities. We obviously wanted to take advantage of the interactive nature where students can move at their own pace, move things around, have embedded info that they can interact with at their own pace. And then also we were really concerned about accessibility. Virtual objects is some very expensive ways to deploy them in platforms, and we wanted to do this in a way that as many students right now could access what we were working on. So we were thinking about that as well. And then just looking at our own resources and Susie's resources and faculty and UBC Studios and how best can we avoid, what's an appropriate amount of resources to spend on these goals that we're moving toward. So there's two phases to a virtual object. One is capturing and the other is deploying in a platform. So of course we start with capturing, tried to figure that out. And we were aware that there are sort of two different distinct ways of approaching capturing, one being 3D scanning, which uses lasers. Here's the Artex spider, which the Hive has one of. And so because of the laser technology, it gets really very high resolution and accuracy, pretty insane accuracy. But it's also very expensive, so that's one layer. Then with photogrammetry, using good old DSLR cameras, not old, but relatively old, compared to the Artex spider. But photogrammetry, because it's photo-based, you get a lot more color and texture information that our eye is able to process in a way that the laser, there's color and texture information from the laser technology, but the photos often get there quicker. And it's less expensive and more accessible. And then you can also combine the two, so that was another consideration. You can 3D scan an object and then photogrammetry the same object, use the 3D scan as the super accurate base, and then stretch the photo skin over top. So we, looking at the pedagogical goals with Susie, we were realizing that and we were lucky enough to be able to try both, which was a pretty fantastic opportunity for us to try both and then show them to faculty and talk about what route to take. So as I mentioned, Claudia and Ishan gave us access to 3D scanning, and we were able to scan both a bear skull and a rat in their lab, which was a lot of fun. And then we also set up a photogrammetry setup here and did the same with the same objects, bear skull and rat, and produced 3D objects of both, and compared the two and showed them both to Susie and Cole Burton, another faculty member at forestry, and asked, like, for your students in the identification course, what do you need? Which of these are helpful and in what ways? And came to the conclusion at that stage that photogrammetry had enough detail, more detail than they needed, so we weren't worried about getting the full detail of the 3D scanning, but it also provided color and texture that was really helpful and was more accessible in a few ways, just in terms of technology. We were able to just do it here. So the approach that we took for the photogrammetry test that we did was to set up in behind me here. So we just had our Diva lights that we use for video with diffusion on them. You want to diffuse your lights so you don't get hot spots on the object. We put it on a turntable. We had our SLR camera. And basically for the software to be able to deal with it. Oh, I should also mention, before I dig into it, just that this technology is not new. People have been doing this for quite a while. You can do it in your home. Part of what's different recently is that the software that processes all of this has become a lot cheaper and more accessible and faster. So we were able to process it in a way that would make sense to try to produce objects for faculty. So basically you put your object on the turntable. You want the entire object to be on focus, even exposure, and no lens distortion. So you can't use wide angle lens, so we use the DSLR with the prime lens in order to avoid distortion. And you take a series of photos, you want at least, for each 360-degree rotation, you want at least 36 images, so every 10 degrees at least. And you also want to get from a series of angles. And the angles need to be within 30 degrees of each other. These are things that we played around with and found the limitations of. We heard that these were true and discovered that, in fact, that's what you need. So we just moved our single SLR camera up to different heights on the tripod, moved through to different angles and different rotations. Then you have to do the same thing with the object upside down. Took all those photos, brought them into reality capture. So on the left you can see hundreds of photos that we just dropped into the software, and I don't know, was it an hour it took to process, Andrew? Maybe less?
Like 40 minutes, yeah.
40 minutes. And it spat out a really high resolution, beautiful 3D object, which we were quite stunned by. And then the next question, of course, is deployment. So our solution to, our first attempt at making it as accessible and easy to use for students as we could was just to go into good old Sketchfab, which is where you drop your 3D scanned or photogrammetry images these days. So this is our 3D object that we created. You can zoom in and out, and
You're looking up a bear's nose.
yeah, that's right.
It's not something you get to do every day.
Yeah, and this,
Just saying.
as I said, yeah, it's a dangerous thing to do. As I say, we showed this to the faculty partly to ask, is this enough detail for you? And but part of what we realized right away was that we were able to get, just with the photogrammetry, more detail than I can see with my eye on a skull. I've got older eyes, but still, it's, it was more than the students need in terms of for this particular application. So
Yeah.
it's different from other applications, like in medicine. You're going microscopic at times in medicine, so you would want more resolution for certain applications in medicine. But this is, for this particular application, this was sufficient, or more than sufficient. We're also able to, within Sketchfab, just add little hotspots. So there's some information about the complex turbinate webbing within the nose, which is all the surface area that allows them to have a super sensitive smelling ability. And then the zygomatic arch, which is pronounced on the bear, protects the eye. So this is something that could be made available online for the students to go to at their own time and provide whatever hotspots you'd want. And ultimately, what we'd love to do is take the whole forestry collection and the whole Museum of Anthropology collection and the whole Beatty collection and have them all available like this. That's sort of where we all leapt to immediately.
Just imagine you could see a passenger pigeon.
Yeah, extinct animals is one of the exciting territories that, yeah. And objects that you really don't want people to handle, such as cultural objects at the Museum of Anthropology, if we can have access long enough to scan and get them up. So let me just see what else. So yeah, deployment is really, of course, once you've captured, this was our immediate solution for deployment, was to get it up on Sketchfab, but it's easy to leap to, also we could take this OBJ file, put it in Unity, and then if students have access to a headset, they could be walking around it, looking at it, shrinking, enlarging, and then you can get into the HoloLens, where Claudia has worked with having an instructor mode where a variety of students are looking at the same object, and the instructor is moving and enlarging and taking pieces off while the students look. So these OBJ files, again, could go into that context. And also augmented reality is another place where it could land in the end. And so I assume that it's not long until students have access to those kinds of materials and platforms to make that easy. But for the moment, this is a way that it can be generally accessible. And I'm out of time.